Welcome everyone. In this video we are going to analyze refraction in flat surfaces. Our analysis will actually be easy because we will use a formula that we already derived. The formula that we will use is the formula for refraction in spherical surfaces, which you can access from the cards right now and from the descriptions part. That formula is n1 divided by a plus n2 divided by b is equal to n2 minus n1 divided by r. Now you might be saying, hold on a second, as you said, this is the formula for refraction in spherical surfaces. Why do we use this? I mean, how can this help us in our proof? Notice this. This formula is correct, for example, in this kind of a case. We have r, the radius of curvature. And this is a spherical surface, as you can see. However, we can translate this formula to fit a flat surface. In a flat surface, what will change? Well, we can keep the A same. We can still have the light coming from the same point, and even B can stay the same. But, and of course, N1 and N2 refractive indexes, they don't change. But one thing is going to change, and it is going to be a huge change. R is going to change. And how is it going to change? Well, look at this picture. Or actually, let me draw a few others. Maybe we have a radius of curvature that is representing this guy. Then it is becoming flatter, and the radius of curvature increases. And it is becoming a little flatter. The radius of curvature increases. And when the surface becomes flat, then the radius of curvature goes to infinity. Okay? I hope this makes sense. For flat surfaces, we have a radius of curvature that is very huge. So in the limit, it is going to infinity. So we say for flat surfaces, oops, I couldn't write. Let me do it again. For flat surfaces, radius of curvature r goes to infinity. As a result, we divide by a number that is very big. So we get a very tiny number. So this goes to 0. And if we, subtract n2 divided by b from both sides, we get the desired equation, that is n1 divided by a is equal to negative n2 divided by b. And this is actually the formula. We are done. However, I want to point out an interesting fact here. This negative sign is telling us a very important point. What might that be? Well, consider this. N1 is a positive value. N2 is a positive value. This is by definition correct because refractive index is defined as the speed of light in the space divided by its velocity in the medium that we are interested in. So n is a positive number. Okay, it is in fact greater than or equal to 1. So we got that. And then we have something interesting. We have A, B, and a negative sign. This means A and B cannot possibly have the same sign. If A is positive, B must be negative. If B is positive, then A must be negative. Okay, I hope this makes sense from the formula. I mean, this is what the equation is telling us. But how does this correlate with the reality? Well, in fact, this is telling us if we have the surface, a flat refracting surface, and we have, let's say, a principal axis that we have chosen. It doesn't really matter in this case. And we have our light beam. It is coming like this. Well, this means when it is refracted, it will refract in such a manner, perhaps it will go like this, such that the refracted light will never, ever cross the principal axis. Only its extension will cross it, okay? The extension will cross it. This is going to be RB, and this will be A, of course. Because how do I know that the refracted light doesn't cross the principal axis? I know it from the negative, because we use a negative when the extension of the light beam crosses the principal axis. And of course, you could do the same argument for A, the incoming ray as well. Okay, so what do we get? We get that for flat surfaces, when we have a refraction, the refracted light never touches the principal axis again, or vice versa. If it touches the principal axis, this means that the original light beam did not touch our principal axis. Anyways, I hope this video was helpful. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.